entrepreneurship, and because he himself is a entrepreneur, he created his own startup and now running the company. So this is one of his favorite topics. So when I asked him, he readily agreed to give this talk, as he has given this talk to many academic institutions. So, so this week we found him to be convenient because he's little away from the busy Bangalore and chilling. So I thought we'll have it today. So welcome Ajit for this talk. Now the IEEE organizers will take over and introduce you and start the talk. Thanks, Ajit.
Thank you, Dr.
Thank you, sir. Good afternoon, everyone present here. My name is Shaleen Bhatnagar. I am Assistant Professor in Department of Computer Science and Engineering, Presidency University. I extend a warm welcome to everyone joined for this webinar on designing IoT solution organized by IEEE Student Branch, Presidency University in association with IEEE Bangalore section and Department of Computer Science and Engineering. IEEE is world's largest technical and professional society. It is also publishing a significant amount of electrical engineering and computer science literature in the world. It provides a wide range of quality publication and make an exchange of technical knowledge and information possible among technology professionals. IEEE offers access to technical innovation, cutting-edge information, networking opportunities, introduce career in technology to students around the world, and many more other benefits. IEEE Presidency University Student Branch is successfully running from past 11 months, and in association with IEEE Bangalore section, we have organized 8 events till now. That includes 1 international workshop, 1 international webinar, and 5 national expert talks focusing on today's most relevant technical topics locally and globally. Today, I'm profusely elated to introduce to you all with our speaker. Today, we have with us Mr. Ajit Balakumar, founder and CEO, Fourth Code Technology, India and Netherlands. He comes with a vast experience in merger and acquisition, investment management, IT strategy with a specialization in IT modernization and data analytics. He did his BTech from NIT Calicut, and he is alumnus of Indian Institute of Management, Bangalore. And he did his specialization in corporate finance from Stockholm School of Economics, Sweden. He has strong understanding of niche technology like IoT, data analytics, and mobility. He has been IT advisor for Karnataka Urban Water Supply and Drainage Board, where he worked on IT modernization, focusing on smart city implementation. Also, he has worked as lead consultant and member of senior leadership team at ULTS, where he was responsible for delivery, solution and architecture, managing 100 plus developers and managers. His list of achievement includes business consultation for one or more for one of the largest IT hardware company for government sector, deals and consultation to various banking and healthcare software product companies. He has been advisor to largest NBFC and telecom operators in India. He has been architect for development of IT security compliance software from the Big Four consultancy firm in Middle East and augmented reality app from Amsterdam-based client. We are very happy to have you with us, sir. Over to you.
Shaleen, thank you for a very detailed introduction. Professor Jacob, thanks a lot for inviting me again for a session in Presidency University. Like you said, IoT and entrepreneurship is two very interesting topic, which I'm really keen to basically talk about. So this session we will focus mainly on understanding of some IoT solution architecture. We will discuss about a couple of projects. We will discuss about a couple of use cases. Once the session is over, we can actually have some question and answers to understand anything in detail. Subsequently, also, I'm more than happy to basically revert any questions in detail in mail also. So being said that, let's start the session. I'll share my screen. Can you see my screen now?
Yes, sir.
Okay.
Yes,
Thank
sir.
you. Okay, thank you. So as I said, we look at designing IoT solution. We look at various components of IoT solution. We look at some use cases, and we will take it forward from there. To give you a little background on my expertise, what I have done in the past, two projects which I think that are very key IT projects in my career. One is an IoT-based smart city implementation in Eindhoven in Netherlands. When this smart city buzzword started, so governments were looking at implementing smart cities and all. Eindhoven, or Netherlands government, they wanted to basically set up sort of a lab where they can build IoT use cases, and which, if found good for the government and the people, then they would like to roll out nationwide. So that project was called Living Labs. I'm also a big advocate of implementing such kind of living labs in India, because if you know Indian government's policy of implementing 100 plus smart cities, it's not a very good idea to basically just open up such kind of large projects and kind of $50+ billion for random experiments. Instead, we should have created a living lab kind of a concept and set up some IoT use cases which is specific for Indian market. Right now, what I see is like a lot of IoT projects, concepts from US and Europe implemented straight away in India, which is not relevant for Indian market. So concept of living labs is citizens basically test the use cases and they gave feedback. Based on that feedback, government select what projects needs to be implemented. So next slide, I'll explain a little bit in detail what exactly we did in this implementation in Eindhoven. So second project is in India. I'm really proud to be associated with this project. This project was kind of a pilot project for GST department and revenue ministry in Kerala. They wanted to basically monitor vehicles coming from other states to see whether they have already created a e-way bill and how many times they have passed the checkpost, which all checkposts they have passed, and etc. The pilot project was in a place called Walayar. So what we did is automated number plate reading system implemented based on cameras. So a camera will basically read a number plate. First, you have to identify a vehicle. Then once you identify a vehicle, you locate the number plate, and then you basically read what you find in that number plate. And this information will go back to a central system, which will basically compare that number plate value with the GST database. So this is one of the best implementation, I believe, currently in India for automated number plate reading system, and which compares with GST as well. So coming to the implementation of IoT-based smart city solution in Eindhoven, this was again a pilot project. Like I said, part of Living Labs. So they have given us a area, specifically a street. That street is called Stratham's End. So our challenge was to basically first identify a platform. They wanted an open source scalable platform to implement this project. Main goal was to basically implement a crowd management system based on IoT system. So we basically looked at various components. You can see from the two screenshots. One, we were monitoring weather data. We are connecting our system to the weather database, number one. Number two, we had multiple sensors in the street and in and around the street. We deployed sound sensors, or which basically identify type of sound. To give you an example, if there is a gunshot, it'll trigger an alert saying that okay, there is a gunshot warning, and approximate location from where the gunshot has been originated, number one. At the same time, in simple and regular use, it also monitor the decibel levels to understand if too much noise is created by a crowd. If it is too much crowd is there, how do we control them without a law enforcement team not getting involved? We also monitor other social media platforms. So we combine data from existing data sets, social media platforms, and sensors, combine it, and basically decide our strategy in controlling controlling the crowd in the street. So one of the use case we implemented is if there are smart cameras there, there are microphones or audio sensors there, smart lightings were there, smart car parking monitors were there in that area. So various use cases were implemented, but one of the best use case was two end of the street had different characteristics in sense of access to that location. To give you an example, in one of the site, it was easy for law enforcement team like police to basically come if there is a trouble. In the other end, it was not the same. So this case implementation we have done is basically if the crowd is too much in one end of the street where it is difficult for police to reach, we basically, and if they are making noise based on the sound sensors, audio analytics, we basically increase the intensity of the light, the smart light, and change the color from warm to cold, and increase the brightness to basically disperse the crowd from that end to the next end without a law enforcement team getting involved. So this is, there are 4 different levels of smart city maturity. So this is this use case is one of the top maturity use case where we are using multiple sensors to get information to take action on certain things, and without a manual intervention, we are basically controlling the entire situation. So high level some use cases. Right now you might have seen that in India there are 100 plus smart cities has been started working. They are working on quite a lot of basic smart city cases. So to give you an example, they look at street lighting, they look at smart highways, These are the kind of projects right now. We are focusing now water utility meter reading, mapping of your pipelines, water pipelines, etc., etc. So these are the basic IoT projects currently we have in India. But there are other use cases for IoT. One of the strong evolving area is digital twin. To give you an example, if you have a machine or even a city, you can create a digital twin in a computer. You can have some sensors in the machine or in the city to basically decide maintenance, preventive maintenance, etc. To give you an example, let's assume that we have implemented IoT for street lights, and we know a bulb has got a life of, let's say, 10,000 hours, and if it is also impacted with the number of times it is switched on and switched off. So a digital twin will basically show a map of let's say an area where we have created digital twin. It will show in the map where exactly each light is, and when did that light is installed, how many times it has switched on, switched off, how many hours it was burning, the light is burning. Based on this, you will understand that which bulb will fail, and you can do a preventive maintenance. This is a very simple use case, but there are very complex use cases, especially with heavy machinery, which run into a couple of crores in value. You don't want that equipment to basically break down. The main reason is, like, even if you look at the rentals, it might be charged per day, per hour. So if a couple of days it has to basically shut down to bring some spare part, it's going to cost them a lot. So this information is something which we can actually send back to a platform, and from the platform we can actually understand when a preventive maintenance needs to be done. A large example of that, a successful example, will be Airbus and Boeing basically monitoring their engines remotely. So when Boeing or Airbus basically lease out an aircraft, they also take maintenance contract from airlines. So based on number of hours flown, the area where they have flown, etc., etc., at the speed at which they have flown, etc., this complete data is captured by Airbus and Boeing. This information is used to basically do preventive maintenance and normal maintenance. So this is a very successful model. A large portion of their revenue is coming from this. So then monitoring health of bridges. Initially, monitoring health of bridges is very complex process involving expensive equipments to be fitted for a certain period, and then you will have to take it back because its machine is expensive. Keeping it in that location is difficult. But with IoT, you can have very cost-effective fixed sensors, which will basically monitor the health of the bridge on a regular basis. So you can just fix it and forget, and this will keep on sending information. And whenever there is a deviation from the normal behavior, you can basically trigger a warning. Then somebody can actually come and have a look at it. We discussed about smart cities. Most of these components are part of the smart cities. In smart city, IoT devices can actually help. IoT, not just devices, but the platform can help a city make informed decision. Mainly because there is a lot of data which will basically help them drive towards a sustainable future. Now, part of IoT largely a smarter building concept is coming up in a big way, especially in Europe. They are looking at indoor environment. To give you an example, today I think there was a survey done by IOT Delhi in Delhi schools, and they said that the pollution levels or indoor quality of air is really bad in schools. So this is a research recently done, today published by IIT Delhi regarding schools in Delhi. So now similar kind of thing is very relevant for smart building concepts. So it basically looks at creating healthier, safer, and smarter environment, whether it is a residential complex or it's a educational institution or if it is a commercial property. So now let's look at what are the building blocks of a IoT solution. So at a higher level, we have 6 components: sensors, and then there are nodes, then gateways, and platform. Platform will reside in a IT infrastructure, just like your computer or a cloud infrastructure or a state data center. Then on top of it, there will be applications. So there are known sensors. We know sensors for quite some time. It is not a very new thing that, okay, there are some IoT sensors. These are all sensors which is already there, where you measure temperature, pressure, sound, vibration, all those kinds of gyroscope. All those things are already there, but with the evolvence of this IoT concept, sensors become very energy efficient. We look at energy efficiency as the first component, because I should be in a position to basically fit a sensor in a node and just drop it in a forest, which will basically monitor if there is pouches in the forest or presence of some wild life and things like that. So there are multiple type of nodes possible. Nodes also could be very energy consuming, very little energy consuming nodes is possible. So sensors plus node is what you normally deploy in areas, and nodes will basically send this communication to gateways. So communication protocol also evolved during this time. So there are quite a lot of IoT specific communication protocols. One of the most successful communication protocol is LoRa communication protocol. LoRaWAN implementation happened in many parts of the world, and now I can see that in Indian context also a lot of companies are implementing LoRaWAN based utility metering systems, LoRaWAN based street light controlling systems, etc. One of the advantages of LoRaWAN is the energy consumption. LoRaWAN is a long-range, low-power communication protocol. At the same time, the bandwidth of that communication is very little. It might be able to send, let's say, 50 bytes. So you can't send images or video through LoRa communication protocol. So that is where the advantage of nodes come in. Sensor will basically detect an image. Let's assume that there is a movement, or they want to track for human beings in forest. So imagine sensors takes a photo. Nodes basically understand node is a let's say microcontroller or a mini computer. Node will basically pre-process that information, understand there is a human in the picture. It will basically send that basic information, yes or no, or 0 or 1 to gateways, saying that okay, I have detected something, or maybe with even a confidence level, say that okay, I'm 90% confident that this is a human being, and that information goes back to gateway. So 3 or 4 characters is what a gateway will receive, even though a gateway can receive even more, but 50 KB is kind of 50 bytes is kind of what they can send. So the way, so this is one of the communication protocol. Then a lot of people use BLE for before coming to BLE. LoRaWAN's advantages you can get at least 2.1 kilometers, 2 to 2.1 kilometer range in urban conditions. In Bangalore, when we tested, we got 2.1 kilometers by just keeping it above a 4-story building. But LoRaWAN claimed to have transmitted from satellites to ground, even at 200-300 kilometers range. That's what they claim. And if it is a beach with no concrete building in between, they have transmitted almost 15 kilometers to 20 kilometers. So these numbers are good, but when reliability comes into picture, around 2.5 kilometers is what we can reliably deploy a LoRaWAN for per gateway. So it's very cost-effective gateway per node. So you can connect almost 4,000, 5,000 nodes to one gateway. Now, if you look at BLE, BLE will give you somewhere around 20 meters to 40 meters maximum range, and number of nodes it can connect also is very low. BLE is nothing but Bluetooth Low Energy. Then you have Sigfox, Zigbee, various other components. It's very important to basically understand the use case and the load which you have to send and the frequency in which you have to send and the availability of power while you decide which communication protocol you have to use, because end of the day that communication protocol is where the entire success of the entire system remains. Once the node send LoRaWAN communication or a Zigbee, Sigfox, BLE, LTE, IOT, now GSM kind of companies. So let's say our telecom providers are also coming with LTE 0, another protocol for, and then a lot of people are saying that 5G is for IoT, but I'm not really clear about that part because 5G sensor will need quite a lot of power to basically transmit this information. So I'm not really convinced 5G is for IoT communication, but of course it is for making Internet of Things even faster and can transmit more information, because as you're all aware, from 3G to 4G, if you migrate, the distance antenna can transmit comes down, and 4G to 5G it still comes down. And GSM normally a mobile phone it can last for, let's say, a week maximum, but a LoRaWAN gateway, if you do it properly, it can go for a couple of years. Minimum you can get 1 year life for a basic battery and a node. So once the gateway collect the information from nodes, and there will be multiple gateways. All those gateways will be connected to platform. There are multiple platforms. There are platform from IBM. There is platform from GE. There is platforms from smaller players in the market. Of course, there are very complex systems from Siemens and one more large company. So they basically focus more on the industry side. But the platform which we used is a open source platform called 5Air. So it has got around 52 modules. We don't need to use all the modules to basically implement a smart city or smart infrastructure solution. We can use around 7 to 8 modules to basically do that. Normally, it consists of some security module. Then there is a provisioning module. It's called IoT gateway, so or a IoT connector. So if you have multiple communication protocols giving information to this platform, this IoT connector will basically handle that entire the messages. Then it will give the feedback to the platform, the format which platform can actually consume it. So IoT connector is actually part of this IoT platform. Before IoT platform, there will be a security module, which basically take care of the sanity of data coming to this platform. Because normally what happens is like IoT is a new area, so there is quite a lot of unknown security vulnerabilities, so which has to be handled. So that's why there is a security component we have to basically look at when we design a IoT system. So this security component, behind that there is a IoT connector. IoT connector can connect to multiple sources. It can connect to multiple communication protocols. Then behind that, IoT being Internet of Things, we always would like to know the context of that particular thing. When I'm saying thing, it could be a light, it could be a gate, it could be a camera. So we would like to understand what is the current context. So if it is a temperature sensor, it'll say that currently temperature is 28 degrees. So this is the context. So the heart of IoT platform manages this context. But at the same time, we might want historic information also. So there is a historic context is stored in some other module. We can basically fetch that from there to also look at how do we perform for a historic time period. So now you have sensors which basically generate data. Nodes will collect data and send it to gateway. Gateways will basically again collect data from multiple nodes and bring it to platform. Platform has got multiple components which will basically take care of the security, which will take care of connecting to multiple nodes and sensors. Then it comes to a context broker. It is called context broker. And then a historic context will be stored somewhere. And then now this context broker is connected to something called rule engine. Rule engine is it has various data sources from the context broker, historic context, and other sources. So to give you a simple example, if the context of a street light is on, and if the ambient light is more than certain level, switch off. So this is the rule engine. So you don't have to basically manually look at it and switch off. You basically configure this rule there, and you can decide on such change in context. So it is normally called rule engine. Now this can basically go to a digital it's called Sorry, I don't remember the name. So, but what it creates is like shareable data sets. So, Indian government also has got this policy of open data. So yeah, it's like a open data platform. So what happens is like you create a lot of data from sensors, other sources, and what action we have taken and all those kind of stuff. It is very relevant for various uh, departments. To give you an example, let's assume that the switching on and switching off of lights. Let's assume that we need that data to be published. So this open data platforms will basically generate data sets. It'll automatically create APIs, and this can be exposed to researchers. It can be shared with department, and they can consume it the way they want. Now, if it is little more sensitive data, for example, crime information, this information we can give access to because of this open data portal functionality. We can give real-time access to police department, but that's at the same time for a researcher it could be 1 day delayed data. Same platform will manage if you register police for real time and a researcher for 1 day delayed data. So financial information, crime information, etc., can be distributed through this small component. So that's how this 5-6 components, which we can actually implement a simple IoT system, which is very efficient, which can interoperate with others, because this data sets will be created and exposed in JSON, or it can be exposed as APIs. So anybody else can actually take this information and learn. So if you see in Europe, there is this concept of pairing of cities. So what they are doing is like they will share certain data with the other city for them to basically learn from the first city. So if you know, central government has allocated around $50 billion for creating 100 smart cities. What is happening right now is like 100 smart cities using 100 platforms, and this platform doesn't communicate between each other. So biggest challenge is once we are done with this experiment of how to basically set up a smart city and all, if all these cities started generating valuable information, valuable data, if we have to consolidate the entire data at a national level, it is going to create a major problem. So it would have been a very good approach if central government would have said that, okay, all of you can actually have smart city solutions, but that smart city solutions should basically give us an open data access, so that a national level command and control center can be set up. To give you an example, now COVID is spreading. All these 100 cities should have created a open data set for COVID cases. It would have been very easy to basically understand this case, spread of different strains, spread of COVID cases. But if somebody want to not share it, that's a different case. But as a nation, we can actually have policies, something like this, which will help in a bigger way. Now, we have sensors, nodes, gateway, platform. All this has to basically reside somewhere. That is IT infrastructure. IT infrastructure sometimes are very complex because the data involved is a lot. But now there are private clouds. Now there are normal cloud providers. Then we have state data centers where we can actually set up the entire IT infrastructure and take care of all this various platforms to be deployed. Once this 5 components is ready, the most important aspect is application. You generate a lot of data, you store a lot of data, you know what that data is for, but what is the application? So Are you going to create a application to manage parking in a city, or are you going to create an application which will basically capitalize on sensors on street lights to help you better manage the lighting? That is another case. So let's look at select few application. We discussed about smart highways and things like that. Let's just look at a few of them. So one of the main area where government is spending right now and will be spending more will be on smarter highways. A smarter highway has got toll management. Toll management, again, right now, a lot of places it's just in a ad hoc way. You will basically reach there, you will ask them how much it is, then you give money and then go. Now, you might have heard that government is making it mandatory that everyone should have the RFID tag. So that toll management will happen seamlessly through that. So a lot more can be done in the toll management. So this data can be generated from multiple sources. It can be basically combined with this tag. If you basically read the number plate also, we can basically understand whether this tag is somebody else's tag and car is somebody else's. Somebody changed the number plate to basically cross the border. All this information we'll get from smarter systems in place. Traffic signals and signs. You might have seen that most of the junctions, traffic signals are a fixed number, the duration. So to give you an example, one side they would have set it as 60 seconds, and the other side it might be 30 seconds. This is like fixed forever. So imagine the morning traffic will be different, evening traffic will be different. So there is no way they can basically change this at this point of time, other than a cop coming there and changing it manually. So with a proper a camera in place with a video analytics, it's easy to basically identify the volume of traffic as well as if there is a piling up of vehicles in a junction from one side. So based on this, you can definitely set a dynamic number rather than a fixed number like 60 seconds or 30 seconds or 20 seconds or 15 seconds. So of course, the moment passengers are ready to look at the signals and travel, this kind of system will definitely help reduce traffic in most of the locations. Now, traffic lights are not interconnected. So let's assume that there is a long road and we have, let's say, 3 traffic signals. One traffic signal in one direction will be, let's say, 30 seconds. In the if you pass that and come to the next one, it could be 25 seconds, and the next one would be 30 seconds or 40 seconds. So now during really peak hours, there is a possibility that 2 signals will be empty, one signal will be piled up. So this kind of situation can be solved if these 3 traffic signals basically communicate. If we understand that how much is ahead, I can basically delay a red signal in the first traffic signal, and when it comes to a minimum number, we can actually let it go. So this kind of system has to be still evolved. If we can actually implement in something like this in road, this also will help us improve designing of roads. Because right now, if there is a lot of traffic, we will either widen a road or we basically redirect it through other different routes. Right now, we don't have a digital twin of our traffic signal, traffic system. So imagine for Bangalore, we have a digital twin. We know that how exactly this is traveling. I can from a command and control center, I can basically see where is traffic piling up, if there is any possible direction to basically move with smart signs. I can basically give a direction there saying that 2 signals ahead there is a traffic jam, take this deviation so that you can actually avoid. Traffic signal and signs is one area where IoT can play a very good role with good ROI, because it can demonstrate that there is benefit for everyone. And surveillance is a major thing. You might have read that a lot of people are investing a lot of money in facial recognition. They normally say in China, the accuracy levels are very high. They have very good system in place. China has put a lot of effort in mastering image analytics. Of course, that's the way to go, because in many airports in India, for example, in Bangalore, they have put a face recognition system, but unfortunately, it is not working. So still, the technology has to go in a big way. The understanding of facial recognition systems is minimal. But being said that, maybe 5 years down the line, maybe 10 years down the line, we will have extremely brilliant algorithms in place which will have like more than 99% accuracy. Right now, it is quite low. If you get more than 50%, it will be very good system at this point of time. When I'm saying face recognition, if you take a photo right now and if you check right now, everything will be good. You will get a very good accuracy, but that's not the real life situation, right? So, so surveillance is one major component. Surveillance can be not just be with cameras. It can be with various other things. There was an interesting use case of availability of Wi-Fi in a home. So somebody has identified that if the Wi-Fi is on, the residents in that house is in the house, and if when they leave, they'll switch it off. So it's in Europe, and then that was a thief. He basically monitored their complete presence, mainly because of the availability of Wi-Fi. So surveillance is not merely with cameras. Surveillance can be with digital signals. One is this Wi-Fi. Second is in a lot of places you can basically read Bluetooth signals of a phone, identify the IME number or MAC ID or unique identifying number of a passenger. So you can understand if the same passenger is coming back to the same street, if he in what direction he is going, how many people are in his car. All this information can be captured with such kind of gateways. So in airports, they have implemented such kind of systems, BLE triangulation and assessment of MAC ID or IME of phones to understand the way in which a passenger will move inside a airport, to decide where they should be keeping what sort of stores and facilities. So now surveillance in terms of in Kerala, the state police wanted to basically put surveillance system in almost all the exit point from the state, so that they can actually monitor if there is a stolen vehicle moving out of state and things like that. Again, that could be using number plate reading or SIM-based, for example, mobile signals or BLE to identify if somebody has passed that location. Now, a smart highways normally has got emergency phone and SOS systems. IoT is something which can easily provide this facility. So imagine emergency phone or SOS button in a highway connected with drones in the toll plaza. So if I press a SOS button in some place, a drone basically can come from the toll plaza to me within a couple of minutes, if not seconds, and we can actually give the message that okay, tire burst or car breakdown and need help, and drone will validate this request, and this information can pass to the respective party to provide support. Highway lighting is again another major area. Like I said, you can control the lighting based on ambient light conditions. It can be switched on and switched off based on sunrise and sunset. A lot of things we can capture from and control this lighting. Now, ANPR is an integral component of smart highways. ANPR is nothing but automated number plate reading system. It's completely image analytics. There are very strong companies in India who has got very good accuracy in terms of reading number plates. So now smarter vehicles. So normally what happens is like we human beings, we operate systems in a different way. So response to a green signal in a traffic junction is different for me and somebody else. So I might take 1 second to process it. The other guy might have already started. So this kind of behavior creates issues. So we might not think it is actually a problem, but imagine if 2 vehicles can communicate each other and operate on their own. So if I have to, the moment signal change, both our vehicles will start together, because communication is between the vehicles, and vehicles decides when to start. So I'll give you a small video on how the reaction time of human beings affect a traffic jam.
Time to get those wheels in motion. So we can see what's happening, Eddie and I need a better vantage point. Ready, steady, and they're off. Eddie, what are we expecting to see here?
Well, what we've got is a very simple mock-up of a single-lane busy motorway. Everyone's going to try and drive at the same speed, but driver behaviour is not perfect. Some people go a little bit faster, some people go a bit slower, and the traffic will start to bunch up.
As Eddie predicted, some of the drivers start to vary their speeds, and the distance between the cars changes. They begin to bunch up, and sure enough, a cluster of vehicles comes to a standstill. A phantom traffic jam has formed. When we speed up the footage, we can see this traffic jam starting to spread backwards around the circle. And once it starts, it just keeps going.
So all it takes really then is a couple of people to brake or something, and that sets it all off.
Sure, if there are enough cars on the road, something very minor can get magnified into a traffic jam.
So that's what I said, the way in we react to external signals is different, and that can actually pile up and create problem which is otherwise not there. So we discussed about digital twin. So this is an area I strongly believe will evolve. Right now there is a lot of work, but right now I'm not really sure about there is a solid platform where we can actually create a digital twin of anything and everything, and I believe soon it will become something like that. So if you have a car, you want one click download the car's digital twin from car manufacturer's portal, and put modification like you want. And to give you an example, you put high octane fuel. So you basically just put that I put high octane oil all the time and submit it. Now it'll say that, okay, because it is high octane fuel and this is running for quite some time, and this is the pattern in which you are driving, this is the terrain where you are driving, where the dust levels are so much, where the temperature is, ambient temperature is so much, and hence this is how you will have to maintain your engine. To give you a simple example. So right now, such kind of systems are not in place, but definitely that is where the future is. Everyone will have an understanding of what is happening for what is important for them, whether it is a rig in the sea, whether it is a airline engine, or it is a manufacturing robot, or merely a vehicle engine. So whatever it may be, we can actually create a digital twin. Like I said before, digital twin concept will also come into cities where administrator can basically see a digital twin of a city and understand when maintenance happened, which area to focus, and all those kind of stuff. Right now, it is all in Excel sheets, whether so data can reveal a lot of stuff, but at the same time, data can really hide also. If I say growth of India at this point of time is -5%, whether it is per day, per month, per week, per year, these are all the questions we'll have to ask. Number one. Number two, is it only happening for this year, or is it going to continue? All this information is missing, right? So, but if you have something represented in a pictorial way, possible to digitally interact, that will give you much better perspective. So that is the reason why we have charts. Now, going one step beyond chart is basically a digital twin. You basically see a visual of the entire place, and on top of it, you have multiple layers, which basically capture information from the ground to us. To give you an example, if you want to monitor water supply network in any city, right now we don't have a digital twin for the pipes laid in a city, so we don't have any clue on if we need to supply to additional region from where we can actually tap it. Whether if we tap it, well, will the pressure will go down, and hence how many people will get affected. All this information is possible, but there is a lot of effort required at this point of time. I'm sure that maybe 2-3 years down the line, there will be digital twin platforms where cities can just take it and configure the way they want. Structural health monitoring, we discussed a little bit on structural health monitoring. This is specifically for bridges, as quite a lot of money needs to be spent if somebody has got a doubt that, you know, things are not good with some bridge. You need to basically get expensive equipments. You need to set up a cam there. You need to basically monitor all those things there. But with IoT's advance currently, you can basically have very low cost sensors deployed there and leave it there, and remotely you can monitor not only just one bridge, you can basically do multiple bridges. So to give you an example on remote monitoring and management, in Finland and Norway, they are looking at remotely navigating large ships, which basically container ships, which basically doesn't need a captain. So captain will be sitting at a remote location, and he will be navigating the ship from a remote location. So one of the interesting cases of IoT implementation in bridge structural health monitoring or bridge health monitoring is in Netherlands. Netherlands has got hundreds or if not thousands of wooden cycle bridges because Amsterdam area especially is kind of a reclaimed land or a land with a lot of canals. So all across canals they have hundreds and thousands of cycle bridges, which is a wooden bridge, and checking periodically all the bridges for their health was not very easy. So they basically implemented IoT sensors, mainly to measure the sound. They look at the sound and understand if the bridge is in good condition or need maintenance or replacement of the wooden bridge. Smarter cities we discussed a lot. So smarter cities has various components can come in: digital twins, non-intrusive crowd management, the kind of things which we have done in Eindhoven, GPR for utility mapping. GPR is ground penetration radar. You know, we have this water pipelines all over the place, but no, unfortunately, government doesn't have any clue where actually the pipeline is. Most of the blueprints will be outdated and not updated. So GPR can basically map utility pipelines and create a digital twin, which will at a later stage help us take informed decision on where to put a pipe and what should be the diameter of the pipe to supply to X number of households or industries. Video analytics is a major component. Video analytics can actually look at the pattern of people moving in an area. To give you an example, a simple logic like if there is an accident, people will run towards a point, and if there is a threat, people will run away from it. So if you look at a video analytics solution, you can see we can implement a small use case like this to see if there is any accident. So you will have a camera in place. Camera will see the pattern in which people are moving. If they are all converging to one location, we can safely assume that there is some accident happened, and you can send people to basically check what is happening there. If people are moving away from one particular sender, that shows that there is some sort of a threat. So you can actually again send somebody to basically check what is happening there. Then sound analytics, like I mentioned before, gunshot, scream, loud noise, etc., etc. You can actually monitor and take decisions based on that. Another area is like honking. Honking is another nuisance, but very difficult to basically track who is basically honking and when he is honking and all this kind of stuff. Parking is a big thing in smart cities. In Bangalore, MG Road, there is a parking sensor-based implementation, but it seems to be a little tricky implementation. You need to basically first park, and then you have to go to a small unit, a kiosk, to basically make the payment. Then most probably you will realize that okay, your vehicle is not parked in the right place and all this kind of stuff. It can definitely improve, but there are better solutions to basically enable good parking things. AMR is automated meter reading for utility billing. Government is slowly, initially government used to do paper-based automated meter reading. Then they put people to basically generate meter reading based on handheld devices. Now remote automated meter reading is possible. So that is, let's say, energy meter fitted with LoRaWAN can send, let's say, 5,000 household information to one gateway, and then that gateway can connect to electricity department, and they can generate this report on a monthly basis. It can be sent as SMS with a payment link or email with a payment link. So this will reduce a lot of effort right now and inconsistency in generating data. This data can also be analyzed to basically look at the theft in terms of water consumption or electricity consumption. Smarter buildings, we discussed a little bit. Smarter buildings looks at utility, again, consumption of power, consumption of water, security, access levels in various areas, various levels. Then fire safety, heat ventilation part. Then ambience, temperature, humidity, quality of air, etc. Lighting. There are various reports which says that lighting completely affects the performance of the people who was working there. There could be ambient sensors which can basically monitor what sort of light is in each area, and based on what time it is, at what intensity and what color. So the image in the slide is a building in Netherlands called The Edge, and it's supposed to be one of the best smart building, which is highly connected and all this kind of stuff. Above you can see the temperature zones in various part of the building. You can basically control the temperature in various areas to see whether it is right temperature for people to basically sit there and operate. So now next slide is about this is IoT, but there are ways in which people are misusing the concept of IoT. So if you see IoT analytics and or IoT, big data, and blockchain are the keywords. So for anything and everything, people basically apply these three, saying that, okay, yeah, this is a IoT solution, this is a big data solution, this is a blockchain solution, or even if it is not required, they'll say, okay, this is a blockchain based solution. So similar kind of solutions are there for IoT also. Next one is a they call it as a smart tile. Of course, the concept is beautiful, but result is nothing. So I'll just show you a small video. So such kind of multiple companies are there who is basically into generating power when you walk. It's a very beautiful concept, right? We all walk. If we can generate energy, that is beautiful. But the kind of energy you can make while you walk is so minimal. It doesn't make any sense at all. Maybe in future, if there's a different technology which will generate more, I'm not really sure. But a 20 square meter, that is 5 meter into 4 meter implementation of the solution is cost around 1 crore of rupees. So as far as I'm concerned, I look at IoT solutions which is cost effective. When I say cost effective, I want my client to basically make money by implementing an IoT solution. If he's not making a delta, then it is not a solution for me. That is how I look at it. So if any project is there were beautiful cases when I was working in as a consultant for a company in Kerala. They want to automate around 70,000 street lights, but those days it was not making business sense to basically implement automation. So we backed out of that project. It would have been otherwise a large project, but if it is not making financial sense, there is no point in doing. So how do we basically look at a solution architecture? So IoT, big data, and blockchain. First, you'll have to think about first for any solution architecture. First most important aspect is define the problem as clearly as possible, as detailed as possible. That is the first step, and most of the people basically fail there. They will not be able to define the problem clearly. So during our meetings, normally basic stuff I will reiterate to my clients, say that, okay, I'm going to rephrase what you have said. This is what you meant, your problem is. So, and this I will do some 10, 20 times. Whenever they add some more component, I will say, okay, so I'm going to start from the beginning, and okay, this is what you said. My understanding is correct. If you do this, half of the solution is done. If you don't do this, you will never reach the solution. So now we should not look at IoT solution and everything, big data solution and everything. We should not look at blockchain solution and everything. I strongly don't believe in blockchain. I believe that it's a great technology with no use. So, but I understand that there are a lot of different thoughts about it. But when I look at a solution architecture, I look at a solution without IoT, without blockchain, without big data, and then I'll come back and see, is there any scope of getting extra ROI if I implement IoT? So this is where the corporate finance component will come. So I will look at this as a basic solution and improvement to a IoT solution as a project, and I look at the cost of it and return of it and say that, okay, whether does it make sense to basically go the IoT way, and there is a need for IoT to implement. Then implement IoT or big data or blockchain if it is required, and definitely look at the costing, because costing is ROI is the sustainable component in any project. So as smart city, smart project, end of the day, what we are trying to achieve, level 4 or level 5 smart city or smart infrastructure is nothing but sustainable smart city. Sustainability is not attained unless and until you look at the cost effectiveness of it. And I'm saying that you basically put 100 rupees and take 101 rupee. I'm not saying in literal sense. To give you an example, conservation of wildlife, conservation of forest, etc., etc. In one way or the other way, it's giving you ROI. You need to basically define that ROI, and if it makes sense, please go ahead. So that's it from my side, and open for questions.
Thank you for sharing your deep knowledge with us, sir. We will go ahead and take some questions. Just a reminder to all the participants, please be sure to type your questions into the chat window. We already have few questions, so we will start with that. So Miss Prakriti is asking, what are the best simulation tools for smart city project?
Just a second. Can you repeat that question? So, or is it there in the chat already?
Yes, sir, it's in the chat.
Okay, example of smart city implementation. Sorry, which one is that question? Let me just see.
So
Address the questions. Just a second. What are the best simulation tools for smart city projects? It's a very good question. So one of the major challenge is designing what technology to be used, number one. Number two, how many gateways are required. There are multiple problems, whether it is pipeline, whether it is a light management. To give you an example, 70,000 streetlights when we were discussing about. We need to basically look at the geography, what is the topography of that place, what is the distance, what is the buildings in between. So it is a very complex component. So right now there is no standard smart city simulation thing. It's basically you have to calculate based on your experience. So you need to, if you're picking LoRaWAN, you need to understand that, okay, if there is a building in between multiple buildings, for example, if it's an urban area, you know that it will give you around 2.1 kilometer range, and if the height is certain, the gateway is deployed at certain height, it will give you certain length. So right now there is nothing like that, but the FiveWire, which I am referring to, this is open source community, they were discussing to basically create it, but it's very complex thing, right? And it's not just for one lighting implementation. It could be for water pipeline monitoring. So that is that's the reason why I was referring to this digital twin, right? If you have a digital twin, easily you can simulate it. But right now you don't have a very good simulation tools for such kind of implementations. So I hope I clarified that. Then there is a question on how does rule engine function. Rule engine is nothing but an interface where you can basically define rules. So to give an example, we will drop down ambient light, and we will drop down switch on, switch off of current context of light. So now it'll and we'll say if the ambient light is more than X lumens, then change the context to off. So that is how we define. We select the sensor feed. We'll select actions, whether it is switch on, switch off, dim, change the warmth of the light, etc. Can you suggest research problem on smart cities? Research problem on smart cities, one of the problem which I explained on the traffic is one of the major research area. If you can find, I mean, it's not a difficult problem to solve. If you can demonstrate in a small area, Indian government can actually adopt in a big way, and it's a major multi-billion-dollar problem for India. If you need more inputs on that, please mail me. I'll give it in writing. And there is another question from Mr. Prakash. I'm Prakash. How are you going to view IoT with 5G networks, and what are the various IoT opportunities we can leverage along with the deployment of 5G network? See, so there are two things. One is Internet of Things and Internet of Special Things. Okay, so this is what I used to tell everyone. Internet of Things is you have $100 equipment, and you can basically put a $10 monitoring system. What is happening now is you have a $10 street light and you are putting a $100 sensor. So that is why I'm calling Internet of Special Things. So 5G's biggest problem is it is GSM technology. It is not energy efficient till now. Just like I mentioned, if you just put your phone without even phone calls, it might last maximum 5 days, not more than that. If it's a smartphone, it might not even last more than 2 days. So that is the limitation of GSM technology. while compared to LoRaWAN. You don't want to basically monitor, humidity or in the sand for harvest, and for that you deploy a 5G sensor, and every 2 days you will have to dig out the sensor and change the battery and put it back. You imagine that pain. So that is the reason 5G. But being said that, what you can leverage is telecom companies will push really hard for implementing 5G based IoT solutions. They were trying to sell in a big way, but as long as they don't change into a low energy communication, it is going to be a problem. One is the example of smart city implementation in India. So there are quite a lot of smart city implementation we can actually refer to, but these are all now textbook use cases, like smart lighting, smart water monitoring, or smart utility billing, or some smart parking. These are all the cases you can basically look at. To explain this, you should understand there are 4 different levels of smart city maturity. Level 0, or you can call it level 0 or 1, it is basically smart infrastructure. That means a city should have good road, good pipeline, etc., etc. India is at that level. So when you ask what is a smart city implementation in Indian context, we have to look at good infra in place. Now, the second level, or level 1 or level 2 smart city, is where you measure things with one sensor. So to give you an example, I will basically have a street light, and I have a system to basically monitor whether it's switch on or switch off. Now, next level, we normally call level 0, level 1, level 2. So level 2, a smart city, is where you combine 2 information and take a decision. To give you an example, the same street light, I know when it is switch on and switch off. I also have a sensor which basically look at ambient lighting in that place, and then I'll combine this and say that if ambient light is more than this, switch off. If ambient light is less than this, switch on. So that is the level 3. And the level 4 is basically sustainable smart city. That means the project basically generate revenue to basically sustain it. So now, if you're asking for level 3 or level 4 implementation in India, I don't think there is any. Or even level 2 itself. There in some cases in Hyderabad, they have done some street light. Again, it's only on a very small scale. For example, 200 lights or something like that they have implemented, and they are monitoring. Large level implementation is, some people are exploring, but I'm not really sure. What are the disadvantages of smart city implementation, if any? Making something smarter is absolutely not bad. There is no disadvantage for making it smart. But how do you make smart? And again, first we need to define the problem, right? You have a okay place where you implement street lights and automate it, and it is not going to give you any advantage. That is a ridiculous thing. And as a for Indian government, biggest disadvantage is we allocated so much fund for smart cities, but we don't have a centralized data collection process in place. To give you an example, a smart city implementation happened in, let's say, Assam. One happened in Gujarat. One happened in Srinagar. One happened in Kerala. Now, as central government, what are they getting? They're not getting anything. So they have to basically collect data from these 4 states and understand what is happening in each state. and say that, okay, now my fund allocation for the states will be based on information which I gather from these states. This is going to help central government. This is going to help state government. So this is one disadvantage. We basically not connecting. One of the disadvantages. Second disadvantage is we are not thinking. We are basically copying use cases from US and Europe and basically bringing to India, which is again a major disadvantage, because what is working in US and Europe is not relevant to us. To give you an example, switching on and switching off of street lights, we don't have to spend $100 because per light, 500,000 street lights are there in Bangalore. $50 million we'll spend to basically switch on and switch off lights. I don't think that's the right thing to basically do. While we can deploy people like, for 20,000 rupees, one person will go switch on and switch off an area of light in a monthly basis. So right now we have to focus more on meaningful projects and do research in India. We have to basically understand what is relevant for us. How do we actually improve based on the limited resources we already have? That is how we have to look at it, and these are the high-level disadvantages. Is all the nodes are homogeneous in the network, or can we use heterogeneous? So we can actually this is a question from Prakash. I'm not really sure about what he meant by homogeneous and or heterogeneous, but I'll just explain, and then if he has got question, he can actually post it. So like I said, you have let's say a node which is communicating to your one gateway in LoRaWAN. You can have another node in the same place which is basically communicating to another gateway using BLE. So one node could be for temperature measurement, the other one could be for humidity measurement. So I don't know what exactly you are. I hope I have clarified. If it is not there, just put question, I'll answer that. Jitun, on the data security perspective, how could we secure the data? What are the most essential procedures we should consider during the design stage? So, Jitun, data security has to be taken care in multiple places. Data security as such is a big area. Most of these professors will be aware of how to basically identify data and secure data. So one is to ensure the sanctity of data. So you have, let's say, hundreds of thousands of sensors deployed. Now you need to ensure that data which is coming from the sensor is actually from that sensor. So somebody hack into that sensor and give some information. We take decision based on that, and we are going to create problem. So one, we have a data security layer to ensure the sanctity of the devices which is connected to our device. So there will be handshaking signals, etc., etc. Number one. Number two, once this data comes to our historic context recording system, so here, of course, the basic IT security kind of things, you should not allow somebody to hack it. For that, you have to have infrastructure in place to basically protect it. Now, if there are, because of GDPR and related requirements in India, so we need to basically mask data which will individually identify people. So that is one component we can mask is basically encrypt. So this is what we can actually do it. So now procedures that we should consider during the design stage. You should understand what threat caused by each data. So if you understand the threat, you can basically create various ways to basically mitigate it. Okay. So if you know that some data is a personally identifiable data, and this data information can lead to some damage for that individual, you need to basically mask those information and things like that. So it's all about understanding what data you are capturing, what a leak can actually cause. Okay, so that's all. Is that the last question?
Yes, sir. It seems we are done with all the questions. So thank you so much, sir. Now I would like to request Dr. T.K. Thivakaran, Professor and Program Chair, CSE, to give away the vote of thanks.
Thank you, madam. Thank you. Thank you. First of all, I would like to present my sincere thanks to Mr. Ajit sir for his valuable presence in this session, in spite of his some busy commitments. And I would like to thank Dr. sir for getting Ajit sir for this session, where it seems to be very useful for all of us. Say, like especially the faculty community, those who are pursuing the research on it. I think it is more useful. So thank you, Jacob sir. And I would like to thank the organizing committee members and other colleagues, those who are there with us in our department of CSE to go about with this. And I would like to thank all the participants, those who have given their presence for this session. And I think it seems to be very useful to you, all of you. I hope in future also you can be able to get the benefit by interacting with Ajit sir. I think Ajit sir, in future also, I think you can give your support on this. So once again, thank you, Ajit sir and Jacob sir. Thank you to all.
Thanks a lot.
Thank you.
Thank you, everyone, dear participants.
Ajit, before we close, I just have a question. Like you mentioned that in an airport, you can get the information related to passengers passing by from the mobile IMEI number.
Yeah.
But is it allowable? Because it's going to be violation of privacy, no?
Yeah, so, good question. So, how it is done is the airport will know that there is a unique IMEI number moving in this direction, but it will not know that IMEI is mapped to Ajit Balakumar.
We will be getting.
So that way, we are not disclosing or collecting any personally identifiable information. And if you remember this IMEI and MAC IDs, iOS and Android started masking. That means you will not get the moment they switch off and switch on, you will not get the same IDs anymore. So that way, today when you come, I know that you were here and you moved in a certain fashion, but tomorrow if you come, I'll not know the same, it's the same you, but it's only a pattern which I will know. All the passengers coming so much time in the airport and they moved in this direction.
Okay, okay. Yeah, that clarifies.
So all the participants, if anybody has got any more question, you can basically send a mail. I'll respond to that mails. And thanks a lot for organizing this session. And special thanks to Dr. Jacob for inviting me. And this is the second time I'm on this university's talk. I'm really, really thankful to all of you. So I'll log out now.
Yes, sir. Thank you very much, sir. Thank you, sir.
Bye.
Thank you, sir.
Thank you, sir. Thank you all. Thank you, dear participants. The feedback link is shared.
Dear participants, please. Thank you, Jacob sir. Thank you, Prakash sir. We are ending the session now.
Yes, thank you, madam. Thank you all.
Bye.
Bye, bye, sir. Thank you, sir.